Good afternoon or good morning, depending on which side of the country you're on. Welcome to RISB's first ever webinar to talk about upcoming projects that are about to be released out to the general public for consultation. Today we're going to talk about AS 7739.1, Digital Engineering for Rail. This standard has been worked on for around about the last 9 months in collaboration with DIOS Digital and Simon Vaux, who is with us today, to look at how digital engineering can be standardised and implemented throughout the Australian rail industry. This project has had input from over 30 different organisations, and numerous meetings have been held to discuss where we want this standard to go and what we are trying to achieve here. Overall, this standard is part of RISB's major projects division, where we are looking at those really big ticket items that the rail industry is calling for. I'd like now to hand over to Simon, who's going to walk you through the standard, talk about what part one is going to bring to the table, and also what will follow with part two. So Simon, all over to you.
Thank you very much, Chris, and good afternoon, good morning, and hello to everyone who's tuning in today, and also if you're watching this on video at a later time. It's great to have you join us. This is quite an exciting presentation to hit this milestone of having the standard now ready to go for public consultation. So the aim of today is really just to walk you through, we'll provide an overview of the standards. So when you start to carry out your review, you'll have, we'll be able to cover some of the key points and key concepts. Before I get into the presentation though, first of all, just want to thank RISB for the opportunity to hold this event today, and also thank everyone for joining in. So it's great to have you on board, and there will be plenty of time for questions towards the end of today's session. So just a bit about DIOS Digital. DIOS Digital is a bit of a new kid on the block. We started just shy of 12 months ago. And the aim of DIOS is to provide digital strategies for a smarter, more connected world. A lot of you may know me from my former role as Director of Digital Engineering at Transport for New South Wales, where I ran the digital engineering team for about 7 years or so. If you want to find out more information about DIOS, you can jump to the website. Just some of the recent projects I've been working on, things such as Digital Twin Victoria program, Canberra Light Rail Stage 2, Let's Get Wellington Moving with the digital engineering framework there. Doing work with main roads, but the main aim of today, and this is where I stop talking about DIOS, we start talking about AS 7739, Digital Engineering Standard for Rail. So the agenda today, there's going to be 5 key talking points, and then we'll talk about, have a bit of Q&A. First of all, I just want to cover why we going down this path of creating an Australian standard. So what are the key objectives? Then I'll talk about the key concepts. So what are some of the main themes, the content that you'll find in this standard? Now, one thing I'll say is it's different to what you may expect, but we'll cover a lot of those key themes. We'll then talk about the structure of the document. So it's paced out at a certain, well, there's certain sections in there which are each grouped into sections. And then we'll talk about the future of digital engineering in the rail industry. So, right, we get this right. We start to standardize the rail sector for digital engineering. What next? Then finally, next step. So we'll talk about the process of finalizing the standard, and also where we go next with part 2 of AS 7739. And finally, I'll talk for about 40 minutes or so, and that'll give plenty of time for Q&A up until 1 o'clock Sabo. So objectives. First of all, it's worthwhile talking about the landscape of standards that all sort of fall under this broad church of digital engineering. So at a global level, I guess most people on the audience tuning in will be well familiar with ISO 19650 and just the general conventions, terminologies, ways of working that has set. Nationally across Australia, we don't have any government-led initiatives. There was the National Digital Engineering Policy Principles document, which you can still find on the Department of Infrastructure's website. But that was never really taken forward into any form of implementation. So policy was set, but didn't have any follow through. So jurisdictionally, across the 8 states and territories around Australia, there's a variety, and also New Zealand, I should say, there's a variety of different sort of strategies, either at a sort of policy level, at a guidance level, at a technical specification level. And then, so that's at sort of a state territory level. And then at an agency level, you've got various transport agencies around Australia producing their own sort of frameworks, which have even more detail still. So an example on the right there showing the Transport for New South Wales Digital Engineering Framework. So it's a bit of a checkerboard of, you know, all sorts of standards out there. But, you know, as a transport authority, it's hard to know where to get good advice. If you haven't started down this path, what does good look like? Well, you know, one source that a lot of people use is ISO 19650, and I think it's really important to sort of call out a table that is presented right at the beginning of part 1 of ISO 19650. So table 1 in part 1, and this table talks about the digital maturity of BIM according to ISO 19650, and it presents 3 stages, 1, 2, 3. Now, stage 2 is the current maturity of ISO 19650. It's denoted in the standard that they self-aware of being at level or stage 2. Stage 3 is where you start getting into databases and queries and object-based models and more procedural standards, more technical specification. Now the standard doesn't make any sort of apologies about that. It sort of notes that it's the standard's been written for the broadest possible audience. So it's really inclusive on the global stage. But it means that if we want to move forward into more digital specification, we can use ISO 19650 as a starting point, but there's a lot more detail that is required. One last thing I'd say is that in stage 2, the file management or information management is specified in terms of containers. Now, a key theme which we'll talk about more in this presentation is moving away from container-based data management into database data management. Big difference, but we'll get to that. So one of the well, 5 key reasons of why we need to have this national approach. Why is this important? Well, first of all, we need to, we want to try and respond to the expectations for digital collaboration and leadership. I think there's an expectation that we should be collaborating across Australia, you know, and actually defining what good looks like, not just at a policy sort of outcomes sort of level, but on technical solutions, on the detailed processes, because this is a detailed challenge. There's a lot of detail behind this. Second thing, we want to improve investment in government infrastructure. That means that you know, we want to get better at delivering our projects, but we also want to make it easier for industry to work with government. So for any of the government transport agencies that may be specifying digital engineering, if each agency is specifying their own thing, it means that consultancies or delivery partners need to configure their tools many different times over. So that adds complexity that we want to try and address. Thirdly, is harnessing emerging technologies for whole of life benefits. So we don't just want to be using digital tools, digital technologies for single phase of life cycle, make the whole life. As noted, we want to reduce complexity and we want to try and align strategies across jurisdictions. The analogy that you hear over and over is we really just want to avoid a modern day version of the Railguage issues that have plagued Australia in the past. So a new direction. RISB has stepped up. And they put in their business plan for this financial year that they wanted to deliver AS 7739, which is an Australian standard. RISB has the accreditation to publish Australian standards. And so AS 7739 Part 1, Digital Engineering Standard, or Digital Engineering for Rail, Part 1 is all about concepts and principles, and that's what's going to be released around the middle of this year. But we are very quickly following that up with the end of the year with Part 2, the technical requirements. Let's call it the sequel. So together, these 2 standards will provide, firstly, the overview, but secondly, what you can actually put in your tender documents and how to set up your internal technologies and so forth. So let's talk about how this sits in the sort of ANZ sort of market. So we've got on the y-axis which geographic area, starting with the large and drilling down into from international all the way down to program and project level. And across the right, we've got increasing levels of technical detail on another way, from strategies to guidance and managerial processes, all the way down into the weeds for the technical and data specifications. Now, the work that we're publishing tomorrow, part 1, Concepts and Principles, is really sitting at a national level. So each state can have their own levels of standardization, but where do we want to standardize at a national level? Like, we're not trying to take over all like state and agency and project program, but we want to have something that's suitable for a national level, so we can build this national collaboration. And so we want to build on ISO 19650, we want to build on ISO 12006 Part 2, on Uniclass and other things, and improve, and actually get that standardization nationally. So then with Part 2, that's also going to then sit at that national level, but getting down into the sort of technical data specifications. So I hope that sort of at least gives a sense of where this sits. But hopefully, once we get this right, it may start to steer the way state, agency, and project programs also specify digital engineering. So this becomes a foundation that provides good practice. So, okay, the objectives. With part 1, when you can download this tomorrow, you'll see that this document really provides the why, the what, the who, and the when, but it sort of does an introductory job of that. It introduces the concepts that we need to know, it introduces the conventions and the terminologies that I think our industry has been missing. Then when part 2 comes along, this will really provide the detailed technical instruction for how. How do we actually do it on projects? So answering and demystifying a lot of the confusion that may have been plaguing our industry for so long. A key thing that I really want to highlight with part 1 is that this is not intended to be directly referenced in project procurement contracts. What we don't want to see is agencies specifying this project must be delivered in accordance with AS 7739 Part 1. That's not the intent of this. This is guidance. It's not for project specification. That will come around the end of the year when we issue Part 2. Alrighty, so let's talk about some of the key concepts. First of all, a key theme, and this is something that you'll see throughout this presentation. Keep coming back to it. What I'm trying to express with this diagram is that it doesn't matter what stage of the asset lifecycle you're in. It doesn't matter what your role is these days. If you can't manage your data well, then it's difficult for you to do your job. But the flip side to that, it sort of highlights that all activities on our projects, all business, sort of groups are really a data management business. And we need to really recognize that data is the new oil, they say, but more than that, we need to have the capability of how do we specify data? How do we communicate what our data needs are? How do we all together develop these conventions and terminologies so we can actually be clear on specifying, exchanging, reusing data? Now, this isn't just a file management issue. This isn't not just about information containers that I mentioned earlier, but there are definite solutions that we need to build into our industry, and I'll keep coming back to this concept around data management. So first of all, definition of digital engineering. Many definitions out there. If you jump onto Google, you'll find there's about 1.7 hits, or 1.7 billion hits, I should say, sorry, for digital engineering. So what is it? A definition that we've used in this standard is simply a collaborative way of working using semantic data management to enable more productive methods of project delivery and asset management. Fairly succinct, but this concept around semantics is something we'll talk about more, but data management is really what this is about. And we need to build up our capability in how we manage and specify data. A second thing you could say secondary to this definition is that digital engineering is a foundational element for building digital twins, smart infrastructure, and smart cities. So this is a stepping stone. We get this right, what can we achieve next? Next, we can start solving how digital twins will work across agencies, down across in projects, agencies, also jurisdictions, and so forth. But we'll talk about that right at the tail end of the presentation. So key concepts. How do I get rid of this again? Move that down there. Okay, so there's 7 key concepts that I want to discuss in in this that will, when you start reviewing the document, you'll be able to pick up these themes. The first thing I really want to highlight is that when it comes to digital engineering, I mentioned that there's no standard definition. But more than that is that there is currently no central or primary, it's called a body of knowledge for digital engineering. Systems engineering has got CBOK. Project management has got the project management book of knowledge. Even data management by Dharma has got the data management book of knowledge. So there's no professional institution for digital engineering in our sense for the built environment. And there's no primary source of information. So if you Google digital engineering, you're just going to get many different views of what it could be, which is defined by many different parties. So an aim for this standard, especially for part one being concepts and principles, is to provide the basic guidance. What is digital engineering all about? When we describe it, what does this mean? How does this relate with BIM, but how is it separate from BIM? All of these things become apparent. Second key concept is that we need to think beyond BIM. We need to think beyond the common data environment as it's specified in ISO 19650, and we need to think beyond information containers. I won't drill into that one now, but it is definitely a key theme that we'll unpack as we discuss this further. Third one is that modern data management, mentioned data management before, we really want to move our industry away from just, well, the rail industry, from just electronic file management, managing lots of different files, through manual processes, to managing databases, or treating all project deliverables in the form of a database. So that's really the turning point. So the next part is, once you start thinking about databases, we need to start thinking about the role of metadata and the need for semantic interoperability. Now, semantic interoperability is a bit of a mouthful, but essentially it's common language. We want to have machine-readable data that doesn't matter who's produced it, it links together because we've all used the same conventions. We've all used the same terminologies, the same breakdowns. We've got the same standardization. So metadata management is a key part of modern data management. So as I said, we want to think beyond the common data environment. A concept that we've developed for this standard is just at the moment we're calling it CDE 2.0, but it's the connected digital ecosystem. So how do we build the connected digital ecosystem, and how do we then establish the digital asset lifecycle, otherwise known in other circles as the digital thread or the golden thread of information? In the standard, we talk about the digital asset lifecycle, and that's really important. To achieve these things, we need to build capability in data modeling. Data modeling is so essential, and this is really not to be confused with BIM modeling, or there are standards which talk about information models, but in a sort of vague sort of sense, like what's in and out of an information model. Data modeling is a skill in its own right, and the way that data models are often produced is through entity relationship diagrams. If you haven't heard this term before, I strongly recommend just jumping on Google. This is something that I personally believe is really going to drive a change. We talk about digital transformation. This is one of the first steps towards doing that. And lastly, the last key theme or key concept is the emerging digital roles and responsibilities for the asset owner. There are so many activities that the asset owner or the main client needs to take on before we go out to tender for digital engineering deliverables. We'll talk about that as we get through this presentation. So now I have mentioned thinking beyond BIM, and look, I've been in the sort of, well, I first started on this journey about 10 years ago when I was at Transport. We set up the BIM working group. And it took us quite a while to really unpack what is BIM and CAD and GIS. How do these things all fit together? And eventually we came onto this idea that it's really about the evolution of design. So where have we come from? Well, 2D geometric drawings, either done manually with drawing blocks and so forth, to using CAD. and the CAD may be doing cross sections, or it might be drawing things that represent a 3D objects, but still a 2D drawing. So the next evolution, moving on from that, was 3D geometric models, but models that were purely created for visualization. They may have some, basic type metadata associated with it, things around the geometry itself and the color, but that was really about it. So the next stage is, what I describe as BIM, a smart 3D model. So the model has many other forms of metadata associated to it. But the main thing is that, you start considering things around primary keys. In this case, an element code for this type of red toy brick. But once you have that, then you can then link to many other data sources. So your scheduler, works in Primavera P6. If you want to link your BIM model to your Primavera P6 schedule, then how are you going to do that? Well, you want to have common coding. Same with cost, same with your documentation and so forth. So we start looking at how do we have the same sort of primary key information across many different data sources, and how do we do that across many projects consistently? So we need to start thinking about semantics and so forth. And this is where we've been, sort of pushing the envelope with digital engineering. And so we don't just want smart 3D models, we want smart databases. And it means that BIM is just one deliverable out of many in an ecosystem of linked databases. So the real digital transformation then is one where our industry has moved from documents, document management, so project records, and we've gone from having drawing rooms with drawings on sort of big blocks to information or data management. But essentially, information management, a lot of the processes require manual intervention, manually shuffling things around in what is largely file management software. We don't just want that. We want to have, we need to build the skills for metadata management. So we need to think about all deliverables, not just as project files, but as business databases. So if we want to ever have whole of life type information, if we want to get to the end of the projects and be able to have a line of sight backwards, then we need to treat all information as reliable and reusable, and it can be associated and queried and so forth. And if you want to be able to associate and query and cut and dice information, that's SQL, that's a database. So where we came from, when I was at Transport, but also now this is where the standard is going, is one where we looked at how file management is carried out on projects. Now, it could be done using all sorts of amazing modern tools, but at the end of the day, if there's no common standardization, it's around the metadata being associated with each of the objects in these files. It's very hard to ever associate things. So the future state is one where we have consistent metadata associated or within each of the files or associated with the files. So it means we can start then linking everything together. So we can get this connected digital ecosystem of linked databases when everything is managed like a database. So this is the future state, and this is really one of the main themes. So where we talked a bit before about this CDE 2.0, there's steps involved in this. So the first one over on the left here is looking at all data sets should be structured. So they should have consistent forms of metadata and semantics embedded in each of these different data sets. So then they can be managed as discrete databases. The next stage then is this connected digital ecosystem where you don't just have everything just being in siloed databases, but they can be linked. So find me all the information about this asset or the systems of assets. Find me everything produced by this one organization. Find me everything that happened in this location at this point in time, or at this life cycle gate. All of these things can be queried when everything is set up in the form of linked databases. So that is really what we're trying to aim for with CDE 2.0. And so the next stage then, the ecosystem, well, the long-term aim then, is when you don't just have CDE 2.0 on individual projects, but agencies start looking at all their projects being set up this way, or every stage of life cycle set up this way. So then you can consider an ecosystem of connected digital ecosystems. We start building a web of structured data. So the digital asset lifecycle is one where we've got all the different lifecycle stages, and this is just generic lifecycle stages. I'm not sort of picking any one asset lifecycle in particular, but the current state, one of the problems that we've had for many years in our sector is one where we just have file management. We procure a whole bunch of files, we specify files, we procure them, and then at the end of that lifecycle stage, we get a hard drive, so we strip out all the metadata that was used on the project. Then we have to sift through and work out what files we want to chuck into the contract for the next stage. And then, there's this sort of continual recreation of data. And then at the end of the project, we move from a file-based approach into a database approach when we try and wedge everything into whatever facilities management or asset management platforms are being used for operate and maintain. So that's problematic. Now, the future state is one where we set up this connected digital ecosystem, CDE 2.0, at each lifecycle stage. So it means then if we also embed verification processes for how we check and reuse data, it means we can have this linked ecosystem of databases over the lifecycle. And this is really, in my view, the digital asset lifecycle that we want to be trying to achieve. To do that, all right, so we'll put a bookend on that next idea that I really want to get into, because we do want to have time for questions as well, is I just want to give you 2 minutes on data modeling, because this is so powerful. Data modeling is what data architects would use to design a database. And the first step is to create a conceptual data model, and there's plenty of literature, there's textbooks dating 20, 30 years on this stuff. And the first step is to create a conceptual data model. And the beauty of a conceptual data model is that it is software independent, it is hardware independent. Don't think about the technology tools, just think about the data model as a system in its own right. And then once we work out how the system should work, we can then work out what tools we can use to manage the data model. How do we implement it? But so for data modeling, okay, new terms, we want to talk about entities and attributes. So in a database, you have entities, and an entity might be something primary. So program naming is an entity. Projects coding is an entity. Asset, the asset breakdown, so asset classification would be an entity. Project lifecycle stage would be an entity. And within each entity, you have a few things. You've got a whole bunch of attributes, which is data associated to it. So say, for example, if you had, like when you create a login profile for something, for any sort of web page, your primary key will be, say, your email address. And then you'll have all sorts of attributes. So put in your name, your address, your phone number, and so forth. And so those are all attributes for you, but you always have a primary key. And so you have all the data entry fields in your attributes, and then you enter in the values, which are unique for each entry into your, or each object in your database. So you have entities, primary keys, and attributes. Cool with that. So an example of an entity relationship diagram is that you draw the different entities. In this case, so this is a basic example. If you had an online shop, so you have customers, so customer ID and all the details. Over on the right, you've got the product. And so the product ID being a primary key, and then quantity and product type and all the other information. And then when a customer wants to make an order, they create a new order. So there'd be, say, an invoice number. And you then have foreign keys, which links this primary key into here. The product ID becomes a foreign key in here as well. And then you have the details of where that product is going to be sent. So very, very simplistic, but this shows how your different entities can be linked together. And the other thing I'd say is that personally, there's many different types of notation out there. Crow's foot notation I find is pretty effective. That's what this symbology is. It's called a crow's foot because the many symbol kind of looks like a crow's foot. But there's plenty of literature on this too. This was created back in about 1975. And it just is a way of expressing one-to-one, one-to-many, or many-to-many relationship. And in time, we're going to have to start creating a data model that's going to work for our sector. Now, there's many examples of structured data out there. There's organizations that are creating detailed databases, well, detailed spreadsheets of information. And take a step back. If we can create the diagrams that express those, then we can start looking at, well, how do we standardize this stuff? So in AS 7739 Part 1, I've suggested what a breakdown would be of the components in a model. So starting with groups, what are the high-level groups of data that we're going to need? And then what are the entities that are going to sit inside those groups? I've got 3 different types of entities. So master data that will be standardized, possibly by RISB or possibly at a jurisdictional agency level. General entities that get repeated across many different project deliverables. And specialist entities relate specifically to different types of deliverables. So there are attributes of, well, there's types of data that only appear, say, in CAD title blocks. Don't care about them anywhere else, it just only appears in CAD. Same in BIM, same in GIS, same in your schedule. Each type of deliverable is going to have its own specialist attributes and entities, and that's fine. So there are some which are going to be more general, and there are some that need to be standardized. And so if those 3 combined are the different types of entities that sit here. Then once we have these set, then we can look at attributes, and then we can look at the business rules. So how do we make sure that not everything is an open text field when you're putting in the values for things? There are rules around what data is added in. So for the groups, for a very high level, and this is just really introductory, project details, commercial management, work zones, work packages, physical location, physical asset, and so forth. But with specialists, I've come up with 2 groups. So geometry-based deliverables, so site capture could be topographic survey, laser scanning, photogrammetry, utilities location, that kind of thing. And then modeling, CAD, BIM, GIS, all that kind of stuff. So the stuff where you're actually getting on the tools and creating geometry-based deliverables. For information deliverables, documents and registers of data. I believe those should relatively capture most things. If I've missed anything, this is why we're going for public consultation. But next level down with entities, this just is as a starter. This is presented in the standard, and this is nowhere near, it's the first draft. And this is going to be refined in time, but essentially, it would be great to get feedback from people. Now's the chance to sort of mention or raise things, I guess. But say with each group, you've got general entities and you've got master data entities. And then there's the specialist entities I have over on the right here. Now this is, it may not capture everything, and that's fine. This is just explaining the concepts when we get into the, as we sort of break this down. So this gives us a way of having a consistent data model that we can start building collectively and actually standardizing elements of data. So just a little bit more detail on this. This just shows how with a project, commercial management, work zones, work package, physical location, a lot of the smarts from here are actually developed out of Transport for New South Wales in the digital engineering framework. The tricky thing though is that was created specifically for transport. So how do we take a step back and go, okay, this is what's going to work nationally and for, well, ANZ, I should say. But you can sort of see where there's general entities, there's standardized or master data entities, and there's going to be specialist entities. And this will be developed further in AS 7739 Part 2. So how do we actually draw up the detailed data models that with crow's foot notation, capturing the relationships with things, and how do we work out what is suitable to be standardized at a national level that doesn't restrict innovation at a jurisdictional agency or project level. So that's going to be that sort of Goldilocks sweet spot. We don't want too much prescription, but we don't want to have it too flexible either. And that's going to be something that's going to be an interesting conversation to have when we get into Part 2. Alrighty, so a fair amount of content there. I'm sure that's going to possibly raise a few questions, but just for the last sort of 5 minutes I've got or so to present, I'll talk about just some of the data structure and then where to from here. So when you get the document, you'll find that there's 4 main sort of themes. Key concepts, and this is explained in detail. So data management, metadata to support digital engineering, and data modeling. Some of the things that we've discussed today. And then there's business setup, digital engineering project planning, digital engineering project delivery. These things, these concepts and processes are introduced with technical details to be explained in part 2, so at the end of the year. This document, as it stands, is about 100 pages already in part 1, which, you know, there's a fair amount in it, just explaining where this is all going, what is the new terminology and conventions. So, you know, when we get to part 2, it'll be using this, all the conventions and terminologies. Let's drill in a bit more. So one other thing which, last slide I'll talk about the contents of the document, is there is this sort of cartoony or comic type presentation in the document early on in section 1 that breaks down those 12 sections that are sort of showed here. So what do we have? In key concepts, data management. We want to move away from file management and data and want to get into databases. Second thing, metadata to support digital engineering. So we'll drill into semantics, taxonomies, ontologies, and specifically things around classification as well. Big section here about Uniclass. There's a lot of interest in Uniclass 2015, but there's also a lot of uncertainty as to how it's actually used. And so by the end of reading this document, you should have a pretty strong handle on what Uniclass means and how it actually works. And then data modeling. So data architecture, data modeling, and entity relationship diagrams. We sort of covered that a fair bit. The next section, business setup. This is where we talk about the need for this conceptual data model and introduces master data entities and general and specialist entities. Introduces what they mean, and as I say, that these doesn't provide, well, they don't provide the solutions, they provide the terminologies and so forth, how this actually works. So project planning, the next stage, we introduce how projects should be scoped up. There's a great section in there about model-based systems engineering and the importance of systems engineering to manage complexity on projects. We then talk about project data sets. So, you know, understanding what data sets we're going to need to deliver in accordance with the scope as developed by systems engineering. And then we get into the project data model. So how do we move from the high level, or the broad data model to the data entities, so then actually creating the tables of data that needs to be collated and prepared before we actually go out to tender. So this, these codes here, I should say, all, that's for everyone. AO is not Australian Open, it means asset owner. And the asset owner is responsible for doing 4, 5, 6, 7, 8, 9. So then with 10, we then the asset owner or the client and goes out to tender. So you have both the client or the asset owner and the delivery partner all getting involved in project planning or procurement. Delivery, so once the team's on board, they're delivering the project, the delivery partner is then required to produce the digital project deliverables. So the database templates, the data models created over here, are then embedded into the project authoring and data management tools to codify all deliverables. So the output of that means that we achieve structured data sets. So codified project deliverables federated in a digital ecosystem of linked databases. So this is how we achieve CDE 2.0. All right, let's just have a fly through on the future of the rail industry, and then we'll get into questions. So let's take a step back and just really recognize rail projects are complex on many levels. If you just look at the number of different roles and teams that come together to deliver projects, I've got 30 different roles here, and this wouldn't be everybody, but on major projects, you tend to have each one of these roles covered twice, once by the delivery partner, so the designers, the builders, and also on the client side as well. And you know, it just shows that there's this you know, choreography of all these different roles coming together. But at the moment, there's no sense of how each of these different roles should manage data collectively. So what happens is that rail project roles and teams are typically siloed with low levels of data sharing and reuse, and low maturity digital collaboration. They just get on and do the job, you know, deliver the projects. So what we want to have, what we want to install in an organization is this connected digital ecosystem, CDE 2.0. This is really going to enable data sharing, exchange, and reuse through incremental business integration. So when I say incremental business integration, we're not going to try and link everyone into the CDE 2.0 straight away. It's probably going to be staged. So in stage 1, for any organization, they might look at what the priorities are, BIM, CAD, GIS documents, maybe procurement documentation as well. Then in later stages, so stage 2 and stage 3, there'll be other efforts to then integrate other parts of the organization, these existing roles, into CDE 2.0. So this means updating the quality management system, going through their data standards, their processes. This is what digital transformation is really going to take. So let's lift the lid on what is CDE 2.0. Essentially, when you look inside, it is the AS7739 data model. We create the data model, and this makes all the connections. And essentially, this will create databases. So we do all the connections, the automation of data management. So you put data in once, and then it flows into other parts, into other deliverables and so forth. We want to get away from manually shuffling and linking things together. So we set up this data model. So then, once we have this in place, let's talk about the future. We have CDE 2.0, we've got structured data. Where does this go? Well, we hear a lot of talk about the digital twin, and once we finish our project, then that lives in the cloud. We use cloud computing. This is what your digital twin is, but this is only one half of the coin. On the other side, we need to start considering physical infrastructure, introducing IoT remote sensors, edge computing, we set up the connectivity, so 5G networks and so forth, to link your physical infrastructure with your digital twin. So collectively, that builds smart infrastructure. These two things combined. So with smart infrastructure, now we're getting optimized ways of operating our infrastructure. Now, we are talking in the standard about fixed infrastructure, but this has already been done in fleets with GPS scanners and axle, sort of weights and so forth. But the long-term aim, smart infrastructure is a stepping stone for smart cities. Now, the main point of this slide is really to highlight that if we ever want to get serious about standardizing digital twins across our industries, and if we want to start standardizing smart infrastructure in smart cities, if we really want to drive those outcomes effectively, CDE 2.0 and the AS7739 data model is foundational. It really is a central part to achieving these broader goals. So, okay, final slides. Today is public consultation, and tomorrow, so today's webinar, tomorrow on the 10th is when we launch the document. Now, there's going to be 8 weeks of formal consultation. So around April, close all the comments, and then AS7739 Part 1 will be published roughly in June this year. We'll be following that up in Q3 with commencing public consultation for Part 2, and around Q4, Part 2 will then be published as well. So exciting times for seeing these things being released. So final thoughts. I often use this sort of phrase in our presentations, but I do appreciate that there has been a lot of content presented here today. Appreciate for everyone that's stuck with it. Hopefully this is sort of giving you a lot of ideas to think about where this could go, how this relates to your own roles. I hope people take this with an open mind and really try and take this on as an opportunity. So I would say keep calm and go digital. It's definitely an exciting future for our industry, and hopefully this helps really solve a lot of those challenges. So on that note, I'll say thank you very much. I appreciate the opportunity to present today, and now we have about 15 minutes for questions. Thank you.
Great, thank you very much, Simon. A wonderful presentation, and I think you've done a wonderful job of talk about where we've gone with the standard and where we're hoping to go to with Part 2. So great work, thank you very much. The questions have been flooding in. I won't be able to get to all of them, but I will go through as many as I can. The first one that I have here is, will the standard consider a unified coding system to connect different data sources?
Yes. Yes, so when we talk about the three different forms of data entities, so master data, general, and then specialist entities. The master data entities are going to be things that we try and standardize nationally. So that's the whole point of this standard. So each agency currently would probably have their own way of asset classification. And we're not trying to say we're going to steamroll that. We're going to get rid of all classification. But what we could do is say, all right, you can have your own classification, but you map to some common language. So then that enables us to link many different sources together. So that's really a theme in the standard. I'm using semantics to then link data together.
Great, thank you. There's another comment here. Great to see RISB taking the initiative, linking hands across Australia. Is there an intention for state transport authorities to consolidate their efforts eventually too? At the moment, it's very fragmented and DE capability development paths are very separate. There's also a further comment around, is there collaboration for a global standard in this area? So I might take that one if that's all right, Simon. I'll
let
start.
you go for that one, please. Yeah.
Yeah, so look, that's the idea behind this standard, is that when we develop part one and then part two, that it is adopted by rail organisations around Australia. So not only suppliers, but your rail infrastructure managers when working on these projects. So that's the whole concept. Now, when it comes to a global, we are certainly talking to Standards Australia and letting them know what we're doing in this space. There is international interest in this, so there may very well be uptake internationally. For us at RISB, that would be the dream scenario, that this product eventually goes international. So we're certainly having those discussions, but we'll see what happens in the future. Yeah, Simon, did you want to add to that?
No, just everything you said. Yeah, completely aligned with that. You know, it's we're trying to be open as possible. This is going to be available for anyone to download and make comments on. And you know, we just came to sort of move the dial in this space. And so if this does help with organisations outside of Australia, Australia and New Zealand, then fantastic. Hopefully it does.
Absolutely. Another question here. In the AS 7739 data model, is there an intention to integrate functional models into the structure?
Yeah, look, there's what I've come to realize is that there are so many different, I call them ontologies, models that have entities and relationships. And, you know, once we start to, like for me, the systems engineering type models that already exist are very interesting. That is one view of the world. There's many different views and many different organizations or parties all have their own models. This is just trying to come up with a model that allows things to share, but there could be links to functional models. But this, you know, if there's primary keys that we can join to other models, fantastic. But there's going to be many different models that we could hopefully tap into.
There's been a couple of questions, as Simon and I thought there might be, around O&M, fleet and decommissioning, and what that hasn't been mentioned throughout this slideshow. I'll sort of take that, and Simon, you might want to chip in at the back end. But if the decision was made fairly early on in the piece that the standard would only cover up to effectively the end of the construction phase. The reason behind that was, firstly, when we talk about O&M, decommissioning, etc., that's a whole nother world. Now, a lot of organisations already have various systems in place handling operations and maintenance. And then to expect them to completely rebuild those based on a new standard is probably at this point a little bit of a bridge too far. So rather than get bogged down in trying to deal with O&M, at this point, the standard is only going to that stage. Now, this is a multi-part standard, and in the future, we may look at going into how you incorporate O&M into digital engineering, but that's and decommissioning, but that's not consideration at this stage. Simon, did you want to add anything to that or mention fleet?
Yeah, so look, I agree with everything you're saying there, Chris, and you know, it's such a complex beast trying to tackle the O&M phase. So it's not that we are ignoring it. We're just aware that if we try to bite off too much in one go, we'll just get bogged down in complexity. And you know, we're keen to get something out to get started. That's not to say we never want to engage with O&Ms. We'd love to, but you know, to get started on something and to prove that it works would be really valuable. So then when we get to having discussions possibly in future with O&M type people, we can say, look, we know that this part is functional. We know that it's working. We have proven case studies, and that will help them to engage better with O&M type people. With regards to fleet, we don't talk about fleet so much, but that's mainly because fleet goes through a manufactured process, and the design and the life cycle sort of processes of fleet are very different to sort of fixed, I call it civil infrastructure. That doesn't mean I'm only talking about civil engineering, but everything, you know, which is fixed inside the rail corridor. So for now, our primary focus is on that. Once again, a bit like O&M, that's not to say we don't ever want to talk to fleet people, but we're just starting with a few boundaries on our scope, and in time, once we know that this is succeeding, we can look at how else we engage with like these other groups.
Yep, great, thanks, Simon. Another question here. Is there any roadmap suggested for digital transformation in the standard?
Oh, yeah, that did come up. Not as yet. You know, like we discussed whether or not standards give guidance on sort of business change. What we want to do is actually just give guidance on here's what good looks like. But how an organization would implement that is, I don't know if that's the kind of thing that an Australian standard would do. You know, so there could be opportunities for further guidance in the future, but for now, we've sort of left that off scope. We're just trying to, you know, at 100 pages, there's already a ton of material to cover, but in time we could look at something as well. I don't know.
Yeah, and it's something that we could look at in the future. I mean, that's the great thing about developing this in parts, is that it gives us the opportunity to expand on that. I mean, at the moment we're talking about part 1, part 2. Who knows where part 3, 4, 5, 6 could go, and whether there'll be supporting guidance notes, etc., to go with this. So it's a whole library that we could develop here. Next question here I've got. This is a great rail standard, fantastic start. However, rail authorities also happen to be often multimodal. Is there any thoughts on extending scope or exploring areas of road, maritime, or air? I'll just quickly answer that one. So RISB is accredited to deliver rail standards only, so standards that apply directly to the rail industry. So road, air, maritime aren't unfortunately within the scope of RISB. Having said that, Simon and I have been in discussions with the SAS Australia earlier on in the piece to explain to them what we're doing, and they're certainly interested in what we're doing and then how they could maybe start developing a suite of standards that does look at other transport industries. So in one way, I suppose you could say that we are leading the charge here at RISB by developing this rail standard, and that could very well then be taken up by SAS Australia and go, okay, we've got this wonderful document. How do we now look at it from a rail perspective? From a road perspective, maritime perspective, air perspective, etc. So we won't be doing it, but SAS Australia also are very interested in what we're doing here.
If I was to jump in,
yeah, sure.
Sorry, Chris, just quickly, just on that. Yeah, so I think when we discussed had discussions with SAS Australia last year, so Chris and I were both on these calls, we did discuss, well, the first step for RISB, because RISB is just getting on and doing it, which is awesome, was what do we need to standardize? And then there could be a later discussion as to, all right, well, this is looking for rail, but then second to that is what could we potentially generalize? How do we lift that up a notch and just go, okay, this could work across many modes. There's discussions that we could have sometime this year to explore that further, but for now we've just been getting on with the job of producing this.
Absolutely. Another comment here, great presentation, thanks Simon. Many suppliers are international organisations, and with a view to remaining competitive, has the document from a data modelling perspective been developed with international standards in mind, such as ISO 27001 and ISO 8000?
Good question. No, it hasn't. So the main ISOs that are referenced throughout the document are 19650 and 12006 Part 2. But those are standards that are going to be quite interesting to see, you know, how much that can actually shape what is in this standard. So yeah, appreciate the comments, and we can pick that up and have a look at that over the next 2 months.
Great, thank you. Yeah, we've got time for probably one more. Nationally, do you see much of a gap in the current industry, government and private skills, in database management to where it needs to be to achieve CDE 2.0 concept?
That is a ripper of a question. How much time do you have? Yeah, look, I think that just if I try and keep this really succinct, data management isn't something that we've ever really put much value on, and it's quite rare to have people whose primary job is data management. A lot of government organisations look at records management, and so it means that we can tick the box and say, right, freedom of information, we have a record, but the data management, and we have IT, which will set up sort of Windows 365 and Office, you know, well, so Office 365 and Windows 11 and all that stuff. That's cool. But there's been this missing space of building those skills for data management. Hopefully this standard will help to turn the corner on that. And yeah, happy to have further conversations in time once people review the standard and really start to take on this message of this significant importance of data management.
Great, thanks, Simon. Well, that's pretty much all we have time for today. So, look, I'd like to thank everybody for attending today. At one point, we had over 120 people watching this presentation, which shows how interested the industry really is in digital engineering. The next steps now is the standard will be made available for public consultation tomorrow. The best way to keep abreast of what's going on at RISB and as these public consultations become available is to sign up to our newsletter, the Whistleboard. If you go onto the RISB website, risb.com.au, you can sign up for the newsletter and you'll be told as these public consultations and other public consultations come available. So I'd certainly encourage everybody to get on the website and have a look. But for sure, the standard will be available. As Simon mentioned, it will be available for an 8-week consultation. We encourage everybody to have a really good read through the standard, provide some feedback and some suggestions on how the standard could be improved. All of those comments and all the feedback will be reviewed by the development group, and then we'll make any changes to the document as necessary. Concurrently, we have started working on part 2. We've already got a specialist group that are starting to work with Simon on that, and we hope to kick off next week our first meeting around what part 2, the specifications, will look like. So once again, thank you very much, particularly to Simon Vaux from DIOS Digital. Thank you very much for joining us today. Really appreciate your time. I hope everyone has a wonderful day, and we will see you for our next webinar when it becomes available. Thank you very much.
Thank you. Cheers.